Today we're going to be learning how to write cosine and sine equations using graphs and by looking at graphs and doing some simple math to figure out different values. So you can see that I have some things written down right here, and these things can all be assumed just by simply looking at the graph. So first we have our amplitude, and we find this by combining the lowest point and the highest point together and finding the difference in between. So here we have -3 and here we have +1. The difference in between these guys is 4, so our amplitude is going to be 2, and that's where we got that number from. And the reason this is -2 is because this sign, sign right here, is headed downwards first, and that would make the equation negative. If the graph was headed upwards first, like that, it would be a +2. And same thing down here with cosine. Cosine is -2 because normally, if it was a positive equation, it would start up here and work its way down first. So that's where we get the -2 in. And you can see here on this sine equation, I have x plus pi. And I got that from simply looking at our x values on the graph. So we can see we have -0.5 pi here and -pi here. And right here, since this dot is in the middle, we know that it is sine. So then that's where we get this x plus pi, is because we're moving to the left 1 pi. And we can get this -1 from this dotted line right here as it runs through -1. Also, this sine dot right here is at -1, and since sine is always in the middle of the graph, that's where we know the y value from. So what we have to do for the rest of these two equations is we have to figure out the second x value, which is right here. This is for the cosine, and we also have to figure out the period in which this sine or cosine wave spans. So to find that, what we have to do is we have to write PB equals 2 pi, and that is just setting us up for finding the period. So what we know right here is that this graph runs through 0.5 pi and all the way over to -pi. So we know that this is one period of the sine graph, since it goes all the way down to the bottom, all the way down to the top, and ends in the middle again. So if we take these two values and we have -pi on that side, and we have pi over 2, which is the same as 0.5 pi. Which is the same as 0.5 pi. And we combine the two to find the gap in between, sort of like we did with the amplitude. So what we're going to do is the total gap of this is going to be 3 pi over 2. Since, we have a pi over here, well, technically a 2 pi over 2 over here, plus pi over 2 on the right side. Combine those together, get 3 pi over 2. So we know that one period of this this graph is going to be 3 pi over 2. So then what we do next is we simply just plug in this 3 pi over 2 into our equation we wrote down here, PB equals 2 pi. So we'll have 3 pi over 2b equals 2 pi, and then you just divide. So you'll have 2 pi times 2 over 3 pi, because when you're dividing fractions, as you know, you just flip it and multiply. So then we have 4 pi over 3 pi, and then the pi's there cancel. So what we can write here is 4/3 on both of these, since the period does not change between the two graphs, or the two equations, I should say. So then finally what we need to do is we need to find this final x value, which, as we pointed out earlier, is down here just past 0.5 pi, negative 0.5 pi. So we can take this 3 pi over 2 that we found earlier, as that is one period, and if we divide the period in half, it sort of runs along this imaginary line right down the middle there. So you would get to half a period there, and then it flips, and then you have your other half. So what we're trying to find is this x value. So if we divide this by 2, so we'll get 3 pi over 2 times 1/2 to get 3 pi over 4. So this number right here, this 3 pi over 4, is essentially how this is the half a period of what we found earlier, this 4/3. So we have the 3 pi over 4. So this cosine dot is at the very bottom of the half of the period here. So what we can do again is we can just simply divide that again, and we'll get 3 pi over 8. And we take this 3 pi over 8, and what we can do is we can change the negative pi into negative 8 pi over 8 plus 3 pi over 8, which gives us 5 pi over 8. So that is our new, or that's our x value, I should say, for the cosine equation. So to recap how we found that, find the period of the sine wave or cosine wave and divide by 2, and then divide by 2 again and add that to the existing x value here, and that will find the cosine value. So next we have some other problems that we can work on. So I always like to set it up. Y equals, always leave a space too for the amplitude. Y equals sine, space again for the period, x, and then y equals space cosine, space, parentheses x. And we can close up these parentheses somewhere over here because, you know, it won't be too long. So then what we have is we have a rough setup of what our equation will look like. So we can see here that this dot is at negative 1.25 pi. So this again is in the middle of the wave. So we know that it's our x value for sine. So we have negative 1.25 there. So plus 5 pi over 4. And same thing here with the dotted line. It runs through negative 2. So we know that our y value for both these equations is negative 2. So to find our cosine x value, it doesn't line up perfectly with any of the points. It's just slightly off. Draw that a little bit straighter. It's just slightly off. So we're not really sure what it is because we can't assume that it's negative 0.5 pi and we can't assume that it's negative 0.25 pi. So what we need to do is we need to again find the period, and then we will divide by 2 again, and then add on to the furthest x value. So this one is a little bit tricky. We only have half a period showing, so it goes up, goes down, up, and then it doesn't really come quite back down that we can see. We know it does, but we just can't see it. So what we have to do here is we have to find this, which it is close enough to 1.25 that we can assume it is 1.25, since we're not really given any other x values. So our period here is going to be, again, PB equals 2 pi. And so then what we can do here is we can assume that this point right here is directly in between 0.25 pi and 0.5 pi, which would make that 3 pi over 8. It's bigger than a quarter, but less than a half. So this x value for cosine down here is right in between these 2 points. So what we would do is we would find negative 5 pi over 4 plus 3 pi over 8. And then we would change this negative to a positive and multiply this by 2 over 2 so that we have the same denominator. This would end up being 10 pi over 8 plus 3 pi over 8. And this 13 pi over 8 is simply the distance between this last dot here and this middle dot here. And so what we can do is we can take this distance of 13 pi over 8 and we can divide it by 2, which would give us 13 pi over 16, so almost 1. And then we would take negative 5 pi over 4 and multiply that by 4 over 4, so we get the same denominator as here. And then we would have negative 20 pi over 16 plus 13 pi over 16. So that would give us negative 7 pi over 16. And we can just put that in this equation right over here. So we would have x plus 7 pi over 16. Our sine dot is in a weird location. It's in between negative 0.75 pi and negative 0.5 pi, whereas our cosine dot is right at negative pi. So we can have x plus pi for our cosine equation. We don't know our x value for the sine equation yet. That is what we need to find next. But we do know that this dotted line runs through 3, positive 3, so we can just add plus 3 onto the end of that. So next we would need to find the x value of this. And in that we're also going to find the period. So PB equals 2 pi. So we have negative pi over here, so negative pi on this side, that's that guy right there, and this cosine dot up there. And then it ends back up kind of in a weird position. So we're not sure what this is, what this value is right here. So instead of using the cosine part of the graph, we can use the sine part. So we don't know what this is, but we know that it's right in the middle between negative 0.75 pi, negative 0.5 pi, and this period ends back just opposite, in between 0.5 pi and positive 0.75 pi. So anything between 0.75 and a 0.5 is going to be something pi over 8. So between 6 pi over 8 and 4 pi over 8, so that just leaves us 5 pi over 8. And on this side, the same thing, 5 pi over 8. So we cross that guy out because we didn't end up using him. So we know that these guys are 10 pi over 8 apart. And in this, we assume the x value of our sine equation. So we'll come up here and we can write plus 5 pi over 8. And that's just a little shortcut. Usually these graphs are pretty accurate and you can assume points like that unless otherwise stated. So our period is 10 pi over 8, so we plug this into our PB equals 2 pi down here. And so what we would do is we'd have 10 pi over 8b equals 2 pi, and then we divide again, 16 pi over 10 pi, get rid of the pi's, and we're left with 8 over 5. So this equation was a little bit friendlier and a little bit quicker, and now that we got the hang of it, you're able to write sine and cosine equations by looking at a graph. So then to find our the period, we would take this the same number right here, this 13 pi over 8, because we know that this is half a period, since it's just meeting back in the middle and not going back over the top and meeting in the middle. So this is our dot number 2 technically. So this 13 pi over 8 right here is half a period. So what we need to do is we need to multiply that by 2. So that's going to give us 26 pi over 8. And this can be simplified to 13 pi over 4. So we would plug this 13 pi over 4 into our PB equals 2 pi. So we have 13 pi over 4, B equals 2 pi. And then we would divide that. So times 4 over 13 pi, which would give us, we're going to go down here a little bit, that would give us 8 pi over 13 pi, and the pi's cancel out just like before, which leaves us with 8 over 13 for both cosine and sine. So then the last thing that we need to find is the amplitude between the 2 points. So we have -9 here and +5 up here. And this guy, these added together is a difference of 14. So we know we have 7. Now to figure out whether this is positive or negative, we just see which way the graph heads first. So with the sine dot right here, it's headed downwards first, so that'll be negative, since a positive sine graph would go up first, just like the first equation that we worked on. And same thing down here, we have this cosine dot right there, this point, and this is headed upwards first. So we know that this is negative as well, as we know that cosine dots always head downwards first. So that's it for these two equations right here, and that is finding the equation of sine and cosine graphs with half a period. So now we have one more problem, and it's the same as the first problem that we worked on. It gives us a full period that we can work with, and some easier numbers here. So we can start our equation with y equals space sine space parentheses x close parentheses, and y equals space cosine space parentheses x close parentheses. And we can take this excuse me, we can take this -2 down here and this +8 up here, and we know that that's a difference of 10. So our amplitude right here is going to be 5. Now to figure if it's positive or negative, again, we would just simply look at the graph. So we have our cosine dot up here, and it's headed downwards first, so cosine stays positive. But we have our sine dot right here, and that heads downwards first as well. So we know that that guy is negative. So then what we would have to find is